right, so now we're going to be looking at writing an equation for a line if we're given 2 points. Here we have to do a couple steps. The first thing we have to do is slope. And the equation that we're going to use to find slope is on top we're going to subtract our y's. On bottom we're going to subtract our x's. And if you like to think of it, y2 minus y1, x2 minus x1, you can. If you want to just think subtract your y's over subtract your x's, that's lovely as well. Just make sure you go in the same order, going from y to x. And then after we do that, we're going to plug in 2-point slope. And you'll remember from last week, point slope, we made that fill in the blank. And then we solved for y2. So the third thing we did was solve for y. All right, so let's do it. Find our slope. So I'm going to subtract my x's, 6 minus -9. You're going to have a lot of minus and negative with these. Don't get freaked out about it. Go with it. You've got to have the minus and negative. And then 2 minus -1. Minus and negative turns into positive. So if you're doing this in your head, you can absolutely just turn those into pluses. If you're doing this in Desmos, you can do minus and minus. It'll take care of it for you. 6 minus -9 is positive 15. 2 minus -1 is positive 30. 15 divided by 3 is just 5. So that'll be a lovely number to plug into our point slope equation. So the next thing we need to do is point slope. Point slope looks like this. So our middle blank is the slope every time. Our middle blank is that slope. Whether you're given the slope or you find the slope like we just did, that middle blank is slope. Now, your other blanks, what we're going to do is we're going to pick a point and use that point. I like to use a point with all positives if I can, so I'm going to use the point 2, 6. From that point, the x coordinate, which comes first, is going to go next to your x in your equation. And the y coordinate is going to go next to your y. X next to x, y next to y. And that's point slope. That's an equation of a line. So if all you're asked for is an equation, you're done. We're going to solve for y here as well, because we can't do enough practice with that. And here we just need 2 steps. We need to distribute our 5. So y minus 6 is just going to hang out. 5 times x is 5x. 5 times -2 is -10. And then I'm going to add that 6 over. The 6 is like terms with the 10. And there's your equation in slope-intercept form, graphable. Awesome, that's number 2. Let's see if there's another one we can do on this video. Number 4. Again, the first thing we're going to do is find the slope. Why don't you pause the video and go ahead and give it a try, and then let me catch up with you. All right, so slope first. I'm going to do 4 minus 8. In the numerator, subtract my y's. In the denominator, subtract my x's. -3 minus 3. You have to be careful there. We're not going to get a 0 in the denominator. 4 minus 8 is -4. -3 minus 3 is -6. I'm going to clean that up. You can use the fraction 4/6, or you can divide both those by 2 in order to reduce your fraction and get 2/3. That's where that old calculator that you used in middle school could be really helpful for you. You can absolutely use that. Our second step with these is to fill in slope, point slope form, sorry. So when we're filling in point slope, our slope goes in that middle blank. Again, you can put 2/3 there, or you can use 4/6. They're equivalent. And then we're going to pick a point. The point I'm going to pick is 3/8, again, because of all positives. The x is going to go next to my x in my equation. The y is going to go next to the y in my equation. And now we're going to get y all by itself. So we have slope-intercept form. Y minus 8 just hangs out. 2/3 times x is 2/3 x. 2/3 times -3. You can actually absolutely do that in Desmos. The way I do it in my head is this: 2/3 times any whole number is over 1. 2 times 3 is 6. 3 times 1 is 3. 6 divided by 3 is 2. That's a nice one to practice those fraction skills on. And then our last step is going to be to add that 8 over. Again, use Desmos as much as you need to for graphing, for double checking your graphing, and for doing these calculations.